Okay, so let's move on to the 10.4 mechanism of blood clotting. Okay, 10.4.1 justify the necessity for blood clotting mechanism. 10.4.2 describe blood clotting mechanism, and 10.4.3 describe health issue related to blood clotting, thrombosis, embolism, and hemophilia. So let us move on to the topic. Okay, mechanism of blood clotting. Okay, mechanism of blood clotting. So the necessity for blood clotting mechanism. So why we need this blood clotting mechanism? Okay, what happens when your finger is injured? Blood will flow from the wound until you apply pressure directly on the wound. The pressure you apply may appear to restrict bleeding temporarily. However, the blood flow is actually stopped by the blood clotting process. Okay. Why must the blood clot on the wound? Blood clotting will stop or minimize the loss of blood on the injured blood vessel. Blood clotting also prevents microorganisms such as bacteria from entering the bloodstream through the damaged blood vessel. The blood pressure is also maintained because excessive blood loss will lower blood pressure to a dangerous level. So how does blood clotting occur? So the necessity why we need this blood clotting mechanism actually to make sure that to stop or minimize the loss of blood on the injured blood vessel, and then to prevent microorganisms such as bacteria from entering the bloodstream through the damaged blood vessels, and also to maintain the blood pressure. Because excessive blood loss will lower blood pressure to a dangerous level. So these are the necessity for blood clotting mechanism. Okay, now let us move on to the next mechanism of blood clotting. Blood clotting involves a series of chemical reactions that take place in the blood when someone is injured to prevent excessive bleeding. So this is the keyword lah. Okay, why the blood clotting occurs? Because to make sure we can prevent excessive bleeding. Okay. So we read this first, then I will explain by using a simple chart lah, so that you can understand, right? Okay, first, we read first. The coagulated platelets, damaged cells, and clotting factors in the blood plasma will form an activator known as thrombokinase. Okay, this is what happens when the blood vessel damaged or cut. So, the thrombokinase, with the aid of calcium ions and vitamins K, converts prothrombin to thrombin. So, prothrombin to thrombin. So, these are the words that you must remember. The chemical or name for that you must remember. First is the thrombokinase. Then prothrombin, thrombin. What is prothrombin? Prothrombin is inactive plasma protein. So, convert by thrombokinase plus calcium ions and vitamins K into thrombin, active plasma protein that acts as an enzyme. So, the function of thrombokinase actually to convert prothrombin into thrombin. But this thrombokinase must help by the calcium ions and vitamin K. So that's why vitamin K is very important for blood clotting. If you have less blood, vitamin K, you have difficulties to clot the blood lah. The blood clotting process to occur. Okay. So what happened then? Thrombin will catalyze the conversion of fibrinogen to fibrin. So remember fibrinogen, the plasma protein. So fibrinogen is a soluble. So the soluble means it's dissolved. Okay, in the blood plasma, you cannot see this fibrinogen. Actually, it's dissolved. Like you make sugar solution, right? When it dissolves, you cannot see the sugar. Same with this fibrinogen, it's dissolved in the blood plasma, but later after it, the thrombin catalyze the conversion of fibrinogen to the fibrin, so it will change later into fibrin. Fibrin means insoluble, so you can see. Okay, from fibrinogen soluble become fibrin. Fibrin is actually a thread-like protein fiber that forms a network on the wound surface to trap erythrocyte and to close the wound to prevent blood loss. So fibrin is this one, the thread-like protein. This one will be produced when the thrombin convert this fibrinogen into fibrin. Then after that, this network of the protein fiber will trap erythrocyte. It will trap erythrocyte and close the wound to prevent blood loss. So this is how the process of blood clotting. Okay, maybe in the sentence you cannot see or clearly, so why don't we try to make it simple like this, So we try with the first one. Okay, you just write, maybe we use the black color lah. Okay, so I try to write very neatly lah. Okay, try to write neatly. So damage blood vessel, damage of blood vessel, or maybe the blood vessel is cut. Okay, then we stimulates. Okay, stimulates what? Coagulated platelets. Okay, and then damaged cells. Okay, damaged cells. And then also clotting factor. Okay, to do what? To form what? Form thrombokinase. Okay, so this is the first step lah. Whenever we have damage of blood vessels, the blood vessel is cut, it will stimulate coagulated platelets, damaged cell, and protein factors to form thrombokinase. Then thrombokinase, what happen? Here, thrombokinase actually will add the aid of calcium ion, okay, plus the calcium ion, and then plus the vitamin K, okay, will convert what? Convert prothrombin into, so we make this longer, into thrombin. Okay, this is the step lah, step by step. Okay, thrombokinase plus calcium ions plus vitamin K will convert prothrombin into thrombin. Then thrombin later will do what? Will convert what? Convert fibrinogen. Okay, convert fibrinogen into fibrin. Okay, into fibrin. So what is fibrin? Fibrin a thread-like what? Thread-like protein. Okay, protein fiber that forms. Okay, they form what? Forms network on the wound surface. Okay, wound surface. So what happened after that? What happened when the thread-like protein fibers that form network on the food surface? It will then function to what? To trap erythrocyte. Okay, erythrocytes, and close the wound. Okay, so when this happen, these two will when the erythrocyte is trapped and the wound is closed, it will prevent blood loss. So this is how the process of blood clotting occur. You must remember this one. The important is thrombokinase. Okay, and then what happened? Prothrombin to thrombin, fibrinogen to fibrin, and then what happened at last? Okay, so this is the process. Okay.